two 3 kilogram masses have velocities v1 equal to 2 meter per second I plus 3 meter per second j, and v2 equal to 4 meter per second I minus 6 meter per second j. Find the velocity of the center of mass of the system. Well, in this case, each object has velocities in the x and y direction. It's a two-dimensional motion. That means the center of mass velocity will also have an x component and a y component. We calculate them separately. Alright, how do we do that? We will obtain the x and y components of the velocity of the center of mass separately. Now, m1 equal to 3 kilogram, v1x, the velocity of the first object in the x direction is 2 meter per second. Is that right? v1 equal to 2 meter per second I. That 2 meter per second is the velocity in the x direction. So that is your v1x. And the 3 meter per second j is the velocity in the y direction. v1y equal to 3 meter per second. I hope you understood how I identified that. Similarly, we have m2 equal to 3 kilogram and v2x. v2x is 4 meter per second and v2y is negative 6 meter per second. Let's now calculate the velocity of the center of mass in the x direction. Now look at the way I named it. Vx center of mass. In other words, the velocity of the center of mass in the x direction is m1 v1x plus m2 v2x over m1 plus m2, and that is m1 v1x 3 times 2 plus m2 v2x 3 times 4 divided by m1 plus m2. m1 is 3 kilogram, m2 also is 3 kilogram, and that is 3 meter per second I. That is the velocity of the center of mass in the x direction. Similarly, we find the velocity of the center of mass in the y direction. Vy center of mass equal to m1 v1y plus m2 v2y over m1 plus m2. That is m1 v1y is 3 times 3 plus m2 v2y 3 times negative 6 divided by m1 plus m2, and that will be negative 3 over 2 meter per second j. So the velocity of the center of mass now has an x component and a y component. Putting it all together, we get velocity of the center of mass is 3 meter per second I minus 3 over 2 meter per second j. You can leave it like this, or you know how to write that in the magnitude angle form. Try that on your own. Write this in the magnitude angle form. Okay, let's now do another simple problem. 3 balls A, B and C of masses 3 kilogram, 1 kilogram and 1 kilogram respectively are connected by massless rods. It simply means that ignore the mass of the connecting rods, and are located as shown in the figure here. A is located at x equal to 2, y equal to 2. B is located at x equal to 1, y equal to 1. And C is located at x equal to 3, y equal to 0. What are we supposed to find? Find the coordinates of their center of mass. And B, if a force F equal to 12 Newton I is applied to the 3 kilogram ball, what is the acceleration of their center of mass? Well, A has a mass m1 equal to 3 kilogram and is located at 2, x equal to 2, y equal to 2. M2 equal to 1 kilogram is located at x equal to 1, y equal to 1. M3 equal to 1 kilogram is located at x equal to 3, y equal to 0. The x center of mass, the center of mass of these will be somewhere here. It has an x position and a y position. The x position of the center of mass is m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. That will be m1 x1 is 3 times 2 plus m2 x2 is 1 times 1 plus m3 x3 is 1 times 3 divided by m1 plus m2 plus m3 is 3 plus 1 plus 1. Now do that on your own and see whether I got the right answer. That is x center of mass equal to 2. How about the y center of mass? Y center of mass is m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. m1 y1 is 3 times 2. There you are. m2 y2 is 1 times 1 plus m3 y3 is 1 times 0 divided by 3 plus 1 plus 1, and that is 1.4. So where is the location of their center of mass? Their center of mass is at x equal to 2, y equal to 1.4. X equal to 2, y equal to 1.4 is somewhere here. And tell me, we have been told that there is a force F equal to 12 Newton applied to the 3 kilogram ball. There is no force on B or C. The 3 kilogram ball at A is a force of 12 Newton is acting on that. Tell me, what is the net force at the center of mass? Well, the net force at the center of mass is the sum of the forces acting at the different objects of the system. So that will be 12 Newton I plus 0 plus 0. The net force acting on the system is 12 Newton I. Therefore, the acceleration of the system is the net force divided by the total mass. And that is 12 Newton I divided by 5 kilogram, and that is 2.4 meter per second squared is the acceleration of the center of mass. Is that right? I hope that is clear enough, that you have a clear understanding of the center of mass, how to locate the center of mass, how to find the velocity of the center of mass, and how to apply the laws of motion to the motion of the center of mass of a system of objects. I will stop this part of the lesson here and continue with the second part a little later.